Thanks for joining us pretty late today. So my name is Mike Weiner, and I'm presenting with John Wong. We'll talk a little bit in a minute about a little bit about our team and what we do. This is Temporal Query Store and JSON support in SQL Server 2016. Just to set a couple expectations and maybe get a few data points from the room. What we did is we labeled this a 200 session, so it's kind of an overview, basically of these three technologies. And these are three technologies that we have in 2016. Great technologies, requested kind of features and scenarios by a lot of people. And so we'll kind of talk through that. You may be wondering a little bit why we picked these three particular scenarios or features. And there's one team that we actually have in our development org that's basically been working on all three of these features kind of in conjunction with each other. Obviously, a few of them, Temporal and really JSON, happen to be more kind of developer focused, where the query store is going to be probably really nice for kind of DBAs overall in SQL Server 2016. So that's kind of why a little bit on the scope on why we picked them. Again, we'll try and do overviews. If we need to drill down on basically one of the features or scenarios a lot more, we're totally open to questions. If you have them through the session, if we need to, we'll probably push a couple if we get a whole bunch of questions. Just for time's sake, we may actually have to push them to the end, but John and I will definitely be around at the end and after and tomorrow as well. So more than happy to talk to you in depth about some of these technologies and scenarios. So for the room really quickly, who's a DBA? Okay, and developer? Yeah, tons of developers, good. Architect? A few, okay. Hit all of them, so, okay. And how many people have downloaded CTP3 and how about that? How many people have downloaded CTP3 or tested with SQL Server 2016? Any testing? Okay. With these features? Okay. All right. Great. Okay. So let's just go with a quick background. So John and I both work on the SQL CAT team, and CAT stands for Customer Advisory Team. And our goal is really around customer engagement. So we will engage with customers. We will work with customers that are basically testing a lot of our net new features, SQL Server 2016, which is in TAP public preview right now, Azure SQL DB, and new features as they come along, SQL DW. It's actually one of the technologies that John is focused on as well. And our goal is to work with these customers on these challenging engagements, and in doing that, we learn a lot. We want to make the customer successful, but we learn a lot too, and we take those learnings back to help improve the product, and then ultimately to share with you as the community around best practices. So we do have a blog, and again, our current focus is on early adoption scenarios, and we do have a Twitter account that we try and reply back to as well. So with that, the kind of breakdown that we're going to go with is we're going to talk about Temporal, then we'll talk a little bit about JSON. Probably Query Store will take the majority of the time. We'll try and do a couple demos, and if you have questions on that, that'd be great as well. So with that, John.
Okay, thanks. Hi, everybody. Welcome to our session. Thank you for coming. First, I'm going to talk about Temporal. The first thing I want to say is before we go to Temporal is that basically covering what is it and then what the value propositions with the Temporal database and why the need for Temporal. So basically, Temporal is any data that has attached with the time dimension to it, so time context. Think about data warehouse type of data. At any point of time, it's every row within the table. The value holds true only during the period in which the time is specified. An example is a transaction with its date associated with it. So the value proposition there is that a temporal database should be able to provide you the insights on how data change over time. So obviously, the critical is that this is business analytics is needed for this type of information. So some example of the data you're looking for is that what are my sales, for this quarter compared to last quarter, from this fiscal year to last fiscal year, and based on the information, how can I make some changes so I can either meet or exceed or reach my target goals. So the need arise of temporal databases, obviously the traditional databases that we have out there fail to provide you this type of insights. Of course, you can try to do some custom workarounds, application level, but they tend to be complex, expensive, and limited.
So has anybody had a need for temporal data in their apps?
Okay, cool.
And a lot of people kind of written custom solutions to do that. See a lot of nods there. Okay.
So you see the value proposition of having SQL Server does that for you, at the engine level. So do you see that value proposition out there versus having to do that customized, right? Yeah, okay. So who is it for? It's basically targeted for a developer. So it's a lifesaver for a developer because it's automatically track data changes for you without any application rewrites or changes. It provides you the easy capability to query across current and historical data transparently. So a typical customer you see is that financial services, they perform, like I mentioned, data analysis over time, revenues over a certain period of time. And of course, the health and care and financial industries, data forensic, auditing the data, and then of course social networking, so profiling, the user information. So typical scenario is that again, the auditing of the data, forensics, and then there's this concept of time traveling, is that what does my data look like over a certain amount of time? So there might be some kind of replay that if I take a look at the data and then a year ago, or even how is the information that I have compared to this today? So based on that information, you can derive some information for either your financials or your auditing purpose. Again, you can also use it for slowly changing dimension. With having SQL Server doing that for you at the engine level, you basically eliminate all those complex ETL processes, data ingestions to give you that currently right now. And there's the other concept is that the row level repair from history. So if you need any changes to modify the data that you have, you can actually modify it and roll it back at the row level versus having to go through an offline, doing a database backup, and then having restore that type of data. So row level repair, I think that's a really great proposition there. And how to start with temporal. So basically temporal is actually a new object. You actually create a table out there. It's actually an object, and you can specify it as a temporal table. So what you have is that you create, the syntax create temporal table, and then you specify a period for and then the system time. And notice there's also a syntax called alter table. So that's a way for you to convert an existing regular table into a temporal table. The other aspect of it is actually able to migrate the data. So if you have a third-party application that may have proprietary databases that you want to add and temporal, make it a temporal database or table, you can actually do that with that syntax. So what happened there is that whenever you perform any insert, all the daemon operation, the insert, the update, delete, and the merge is actually being written to all the daemon operation and all the querying operation. You just go against a single table. So think of the temporal database. They have two tables actually. So it has the primary tables and it has a historical table. All the interfaces that your operation is actually goes through the primary. Update, delete, all that is all the historical data is going to write to the historical tables whereas when you do a select against the current data, it automatically goes against the primary tables. And then the temporal querying, it provides you some, what we call this temporal predicates over here. So in addition to the data that we write for you, we actually create all these predicates, the end date, the start date. And with this special syntax right here, you can provide some additional analytics to see the data is from between certain time frame, contain, or between. And as you can see, the T-SQL syntax that we provide for you is all NC 2011 compliant. So here's how the system time worked. You insert the bulk data into the primary table, as we call it. And then any update information, the older version goes against the historical table. New data or updated information goes against the primary table. And then here you just do your regular queries. It goes against the current data. And then if there's any data that hit against the historical data, it automatically would either go to the history table, or if the subset combine both the data from the current and historical, it automatically join those information for you and provide you on the result set that you're looking for. So the bottom line is that what we have out there, it just works for all the SQL Server technologies out there in 2016. So security features such as always encrypted, RLS, and data masking, the always on failover cluster and availability group, and in-memory OLTP and column store. And then we also give you the capability to have file group alignment or tier storage. So what you do, you might want to store your primary data in your so-called hot or SSD type to give you better performance. And then you can assign file group for the historical data to maybe cheaper storage. It's sort of like a tier storage type. So it gives you the performance and then the flexibility of hot and cold type of data set. So some of the questions that that we have so far with our preview customers and our experience are.
And John, let me ask just a question for the people in the audience that basically said, hey, yeah, they basically implemented their own or rolled their own. Does this, at least does the high-level scenario kind of ring true? Does it make sense in terms of basically abstracting a lot of the basically heavy-duty work that you have to do, whether it be through triggers or triggers and views and all this other stuff, the data movement aspects, and also basically the ability to, between your regular table and your historical table, and then basically the ability to query across both of them. Question.
Looks fantastic. Just a quick question. Are you able to take what you've already built as far as capturing all that history and load it into the new historical tables, or does it need to just start from zero day one? So in other words, if we were to migrate to this from a proprietary system that we built to do that, can we take that history with us into the new system?
Okay. Do you want to comment on that? Or?
Yeah.
Okay, so the question is basically, hey, I already have basically a proprietary system that's set up, and I probably have some historical data and my regular table. So do you have to start from basically ground zero, or do you need to, or is there any way to basically integrate this? One of the specific things, and we actually listed 5 or 6 common questions that we've got in general around this, but it's actually not one of them, but it goes to one of these points. So the temporal implementation that we do have, and there are a couple different scenarios that I've seen around it. One is basically based on, say, system time, which is actually the way that we do it. There's also kind of an application time-centric implementation that people may have. So we don't truly have support for that today. Ours is all based on system time. So there is some considerations, for example, if you didn't actually have system time columns in there. But if you do have the system time columns, we will let you basically, we can go ahead and create the historical table for you, or you can basically specify it as a historical table, and we can set up the temporal configuration around that. So ultimately, as long as there are a couple constraints around that, but you should be able to not start from scratch. Did I see any other questions? Okay, the question is, does it utilize a lot of space in TempDB? So these are just 2 tables in your user database. There wouldn't be any other external considerations around TempDB outside of just regular 2 tables.
So yeah, when you write your data into, if you insert the data or update the data, for example, update the data against the current database or tables, against the new data writes directly against the primary, and then actually in the background, the whole transaction is a single transaction, and it writes the older version directly against the historical. So TempDB is not being used at all.
Yeah. And for query,
Anybody?
it's the same as regular queries.
Right.
Yeah.
I see a question. No. Okay. So the first question was that what about data retention? You basically if you basically get sometime one of the things is that as you update a lots of data, the historical data can obviously become large, right? And then if you want to follow a certain policy, you want to keep the data 3 years, 7 years, or sometimes up to 10 years. What can you do something to have some kind of sliding window or something? So yes, you can basically either go through a manual delete, or you can go through the sliding window partitioning. You can actually do that to manage the data.
And so maybe it's also a good point that on some of this and some of these technologies as well that we're developing, we are actively working on them, and we see it as, for lack of a better term, kind of a journey. So for things like this, data retention, it's actually ideally we'd like to basically have it all kind of in and working and seamless, and some policies basically around that. But for today, in particular, people asking about the history, data retention is basically you can manually execute basically deletes or a partitioning schemas to basically get rid of older, colder data.
Okay.
Question?
Yeah, as I understand it, there's a scenario where when you update something, it forces the existing record to be archived as if it was, that's how it was at the historical point in time. What I've experienced, there are 2 scenarios. There's some updates where, based on different attributes, some of the attributes when they get updated, you want to archive that and say that's how it was at that point in time. But there's also other attributes where you want the ability to update them but not trigger that archive. Sort of a combination of a type 1, type 2.
Yeah.
Do you have that option to apply the trigger on individual attributes, individual columns?
Okay. I think we can answer that. Yeah, so the quick question is basically, there may be scenarios where you may not want to basically have the value basically move to your history table as of a certain point in time. Maybe some type of transformation of the data or something like that. So the way it's currently implemented, everything should go over to that historical. And I mean, that would basically, yeah, everything would go over to that historical. So you wouldn't be able to do any data transformation in between that.
So one of the things that the feedback we can provide to the product group is that that feedback. Are you looking at like maybe roll certain columns that you don't want, right?
Yeah.
So certain column that you want to say, I'm going to update it, but I don't want you to archive it.
Yeah,
right.
you can see different columns would fall into different categories.
Okay, right. Okay, that's good feedback. This temporary overhead. So insert select, no overhead because you don't have to do anything to the historical data. Whereas there is a slight overhead with update and delete. So as far as we can tell, it's still faster than any other type of workarounds or manual process that you have to do if you have to go through out there and have your own historical type of saving the data.
Right, so obviously, again, just based if you're doing really heavy updates or really heavy deletes, there's going to be basically a lot of transactions that go, and basically you're updating 2 tables there, right? But as John mentioned, again, in a lot of our testing and talking to customers around basically workaround scenarios, these have proven to be much more efficient. And you get other benefits as well, not only just just perf, right? But just ease of use and deployment.
So I think this is back to the question that you had earlier about, if I want total control over the period of validity for my data, do you support some kind of application time instead of the system date time? So application level, if you make changes, and you want to control that timestamp versus letting the system doing that. So the question there is that, obviously right now we only support system time, but we're definitely going to have something like that planned in our roadmap, so it gives you better control over it.
For the people in the audience who have done the implementation, is it mostly based on some kind of app scenario?
How's
Okay.
the system?
Okay.
That was historical time. So modeling historical change, so not systems or application.
Okay.
Specify it at the change.
We would, yeah, okay, so the comment was basically you were modeling it based on,
Like a year ago, what happened a year ago, and what happened 6 months ago, and 2 weeks ago.
yeah, the question is, so if you say a year ago, 6 months ago, the question is, do you basically define that time, or is it based on basically system time? And anything that's not core based on basically the system clock, the system time, is what we're basically calling application centric. Temporal. Quick question.
You were mentioning about the SCD, so slow change intervention type of controls. Now, in some cases, in the slow change intervention, you can actually go and say, with a marker or flag in the code, give me the most up-to-date records. So select where flag equals 1. In a case like this, would you be able to say, query just your active table in an easy method, or if you do do you have to go back to where the time was last updated across the records? Is there an easy way
Yeah.
to get the most current version?
Yeah, so the question is, do I have to do something, I'm going to reiterate the question and then tell me if I'm wrong, but your question is basically, hey, if I just want the hot data, the most current data, is there anything special I basically need to do there? So the question, the answer to that is no. You can basically just query that table. What we, so you query active table and you can get those records. If you want to basically get historical data, if you want to get query between two dates or contains or something like that, we have T-SQL syntax that we've added on top that will basically let you query across the primary table and the historical table and pull that behind. But no, you could just query the regular table as possible.
Query will always go to the primary unless you put the for statement in there or the historical.
Yeah, it'll automatically go to the current data or whatever time ranges that you specify. If it's the latest, then it'll go to the primary one.
Yeah, we'll defer other questions just in the interest of time on Temporal.
Okay. Can I use Temporal to perform full data audit? And yes, you can use that, and of course use it in addition to SQL audit. Right? Can I make schema change? So it does support alter, which basically will make changes to your historical data too. So I'm going to hand over to Mike now to talk about JSON.
Okay, great, thanks, John.
Thanks.
So, yeah, so the first slide basically says JSON is everywhere. It's obviously a very common format of basically data exchange. How many people are working with applications or scenarios which use JSON? Yeah, I expect a ton of this, right? Okay. So, I mean, we basically, these diagrams here, right, basically show cloud services basically communicating over JSON, SaaS type applications or APIs that do a lot of JSON communication, certainly big data integrating, and then kind of relational stores as well. So we've definitely seen that across the board. This was probably based on our Connect feedback. This was one of the top pieces of feedback that we got where people were looking for basically JSON support within the relational engine. So again, kind of the JSON use cases at the top level. Obviously, there's kind of service integration and basically integrating with those modern applications and services easily. Obviously, JSON gives you much more flexibility in terms of basically your schema and making trade-offs there between a fully relational schema and kind of a some less NoSQL type schema or less defined schema, and then kind of the data analysis around parse, query, and analyzing JSON documents. So for the SQL Server 2016 implementation, we had a few kind of targeted scenarios. So I kind of listed them out as kind of CAN scenarios. So the goals for SQL Server 2016 and our JSON implementation are that we can accept JSON, parse it, and store it as relational, that we can export relational data to a JSON format, and that we can correlate both relational and non-relational. So basically, we can query across the JSON data and our relational data. So the JSON implementation, again, our focus on JSON is as a data exchange format. So we're not specifically looking at doing things like one of the questions is, hey, can you take JSON data? Do you do a lot of compression with it? And things of that nature. That's not what we're looking at. We're basically looking at being able to take JSON data, being able to send JSON data out, and basically query across relational and non-relational. So we don't have any custom type or index, no native JSON type or native JSON index specifically. What we do is we store the JSON data as an nvarchar. You can utilize regular indexes on top of that. So you can use a standard B tree. You can use a full text search index on top of it. Anything you can basically put on top of an nvarchar column, you can utilize. Again, some of the common questions after that are, hey, does JSON work with A, B, and C? And basically anything that you do with nvarchar, you can do with JSON in the relational engine. So yes, it works with a number of our other features for our in-memory technologies for memory optimized tables. You can create a nvarchar column on there, and you can store JSON in there. Row-level security, StretchDB, Temporal, encryption, etc. Another common question is, does it work with all client drivers? So again, this is just basically querying SQL Server tables. And this is also, if you think about it, just from a holistic perspective, we also are, haven't announced yet, but soon enough we will be announcing basically support for this in our Azure SQL DB platform as well. So you'll have this on the box in SQL Server 2016, and basically the same code base is running in Azure SQL DB. So you see it there as well. So let's step through just basically a couple of scenarios and the syntax, and I just want to give you a taste of the syntax. Then we'll probably go and do a quick demo as well. So in this particular case, I have a JSON document over here, and we have an OpenJSON function, which can basically query this particular document and input it into a relational format. So basic syntax, and to highlight a few things, again, if I'm looking at the attributes and the key in the attributes and order and number, you can see basically in the OpenJSON syntax, I can basically go declare, again, the number as a varchar type column and point to the path for order.number there and basically specify my JSON attribute, and we will basically create this type of a table using that OpenJSON syntax. Of course, again, just as an example, for the values, again, for number, they can just go right in there into the relational format as well. So as it relates to table to JSON format, so again, this is this kind of second scenario. I have relational data, but I have some type of an app that basically wants to read or I need to communicate with as passing it out as JSON. So in this particular clause, we have for JSON, very similar. How many people have worked with XML in SQL? So this type of syntax as well should look pretty similar, and you get a lot of the same functionality. We have things like JSON path as well. So in this particular case, again, I can just select that particular data, and I specify basically the attribute and then output that as JSON. So this is just the for JSON syntax. So a couple built-in functions. These are kind of the top functions that we have. So is JSON basically tests whether a string contains valid JSON. So if you specify something as is JSON, then if you basically put a constraint on that particular column, that will basically let you ensure that the data that's going in there is properly formatted JSON. JSON value, that extracts a scalar value from a JSON string. The next slide basically talks about an example on indexing, and this is probably a good practice that we'd recommend, which is basically if you have basically core attributes that you really want to search on, basically looking at creating that as a JSON value, those core attributes, and then you can basically put an index on top of that. So that will allow you to seek in and basically utilize that index. And then JSON query extracts an object or an array from a JSON string. There's one more that we'll talk about later on that's coming. I think it's a JSON modify as well. So again, one of the typical kind of questions we get is just around indexing. And this is just a core example. Creating a table, you can see that basically I created the check constraint to ensure that basically the data that's going in to that sales order items column is properly formatted JSON. Again, I'm following kind of this practice where I'm saying, hey, listen, I really, really care about price here. So basically creating this JSON value on top of that, and then I can create an index. Of course, I can include other basically relational or non-JSON specific columns in there as well. Basically query across that. So with that, I think, why don't we go to basically the demo.
Okay.
With the column JSON. This is 8, I think.
Yeah. Before we go there, let me do the next slide.
Oh.
Yeah.
Oh, sorry.
Okay, before we go to the demo, I just want to show you really quick about what we're trying to do here. So basically, we're performing analysis, time series analysis, with on the top, as you can see, the transactional data. So basically, those are the sales type of information. What is a correlation between sales versus social sentiments? So at the bottom is that we're actually taking advantage of SQL Server 2016, supporting JSON, and then have the capability to convert that non-relational format into relational into SQL Server. So we're combining, that relational data with non-relational JSON information, and then we're using Power Pivot, Power Query to do some analysis and show you like a graph trend analysis over that. So, so that's what we're doing. Ready? Yeah.
You want to make the T-SQL bigger? Just 150.
Okay. Okay, so first thing we have is this little script right there. I saved some time, but basically this is just sort of like setting up the environment for us. First thing here is that again, we're trying to do some analysis time series, between sentiment and ERP data over the time, leveraging both technology, Temporal, and also using JSON as one of the input data sources. First thing we want to show you is that we actually, in addition to the feature, we actually introduces some cool syntaxes, as you can see right here, drop object if exists. So before you have to use, checking the sys object with the name blah, blah, blah. So now you just say drop procedure if exists, and then there you have that. So
Yeah, how many people ask for that? Yeah.
Save some typing, right? So next thing I want to point out is that we basically have, this particular table right here. We defined the product table. We defined it as a temporal data, and again, it's combining some the sales data along with the JSON. So what you're noticing here is that we have product name and unit price and sentimental. Notice this is JSON. And here we actually have a JSON constraint. I think Mike discussed about it earlier. So is JSON syntax? That's basically checking to make sure that it's in the valid JSON format. And then here you can we specify the valid from and valid to information. So these are the system generated that provide that for you using the temporal syntaxes. And here you can specify the history table versioning if you wanted to. If you want control over the naming convention, you specify the name yourself. If you don't specify it, it's actually generate a little bit more cryptic history table for you. But bottom line is that it just make it available out there for you, and then you can actually look at it. But almost all of your transactions should be going against the primary tables. Okay. Next thing I want to show you is the. So here's we actually inserting. We started with 5 products that we have information about it. So such information as the product, and then the Facebook numbers, and the LinkedIn count, and the number of Twitter account information. And with that we actually create a view to feed the report for us. And basically this view actually does a transformation of JSON non-relational data into the relational using the open JSON syntaxes that we have out there. So here's the open JSON. We're picking out all the JSON information right there, all these Facebook, the product, and LinkedIn, and basically convert all this information right here into a relational database. So when it goes out there, it's in the SQL Server. So the rest of this script is basically just generate the workload. What it does is that it's actually simulating loading the data into both the ERP data and also the JSON sentiment information. So with that, so what I have here is actually the first one that basically this is actually just goes out there and keep track of all the sentiment, but only at the current data. So this particular data right here is going against the particular, the current primary data only. So I'm going to go ahead and crank up the workload. So as you can see, as we refreshes the data, you start seeing information about the number of total units sold and the correlation that has with the sentiment, Facebook likes. So again, this is information against the current data, current primary tables. If you want to do some trend analysis, we can actually provide that information for you, leveraging against the temporal technology that we have out there, and in addition with the JSON data. So here, as you can see on the top, we have information about the number of Facebook likes, and at the bottom is that the correlation with the number of total units sold. As you can see, that at the bottom is basically a time series. So as you can see, it's by the time series. As you have a certain period amount of time, you can see that there's a correlation differences between the two factor. Okay, that's all I have.
Okay, so let's see. So any questions on temporal or JSON?
The $1 million question, is that enterprise version only?
Okay, so Yeah, I had to wait a session and a half for this question. So, the question is this Enterprise Edition only? So we haven't. I mean, the honest answer is we haven't totally defined basically the additions and features that are in those additions yet. I defer to our marketing team, who I know is actively working on it. But I can say that specific to the JSON, I mean, the other feature is basically coming, like I said, we're putting it in Azure SQL DB. I actually don't know what version specifically in Azure SQL DB, but you'll probably see, I mean, we have a lot of different SKUs basically in Azure SQL DB as well. So I don't have core specific stuff, but good question.
Quick question, does the temporal stuff include user, like a user, so you can see who made the changes and filter that?
Okay, so the question is basically, does temporal include something like a user so you can basically do audit or something like that based on users? So it integrates with, I mean, you can use it with SQL Audit, but temporal is basically just tracking the two tables. It doesn't have any, I mean, you could specify something like that in the app, but there's nothing inherent basically in the technology to do that.
Can you temporarily turn off the temporal if you want to do a bulk update? So let's say you find there's a data error that you have to fix.
Repeat the question.
Yeah, so the question is, can you temporarily turn off the temporal functionality if you want to do like something like a bulk update?
And also, can you update the history table as well?
I'm
You
not
don't
sure. Yeah, no.
We'll follow up offline.
Yeah,
Sorry.
follow up. I'm sorry.
With temporal, your historical table, can you go and put a partitioning strategy on that as well? Or is it just a one?
Yeah, I think we talked earlier about how to maintain the data, so you can do partitioning against it, right? Yeah. The question is that, can we do partition against the historical table? And the answer is yes.
On yours, I have to check. I'm pretty sure you can.
Does temporal have an impact on CDC?
Temporal has an impact on CDC? Well, actually, we have some people that actually use this in addition to CDC, right? It could be not a replacement because there's actually some extra work around it, but we do see some user actually going out there and use it with a little extra work to replace the current CDC if they don't, say, want to use Attunity, for example, to save some money.
So it doesn't have an impact when it comes out.
Yeah, no.
Applications that have CDC will still be operational.
Right, right. Yeah, again, we talk about no application changes, so it should not affect anything.
Other
Okay.
questions? You have a question?
Is temporal a good candidate for update triggers, insert update trigger, like a replacement of insert update trigger? Normally it does a history.
Yes, so before, temporal, right? Yeah, before temporal, that people actually use that as one of the workarounds is to use triggers.
Yeah. So the question was on triggers, basically, and yeah, is temporal a good potential solution to?
Yeah.
So yeah, I mean, that's been one of the common ways that people basically try to move historical
Is
data.
there a rollback option available for temporal where we can go back in time and specify this is the row and key?
Well, I think that was the, remember the roll backup that we talked about earlier? So you can actually do that, right? You can roll it back to the data if, the data is corrupted or somebody inadvertently delete the data or whatever the case is.
Was that your question? Okay. Yep.
Just the JSON stuff, how does that something like the entity framework?
How does it work with something like entity framework? In the sense of basically, yeah, I mean, I don't think that you should have, yeah, I don't think that there should be any, there's nothing, so the question is, how does it work with JSON with entity framework? There shouldn't be anything implicit that would basically prevent you from using either of those functionalities in conjunction with one another, but we can actually, maybe if you have a little bit more on your scenario, we can take it offline and drill down on it. Definitely be interested in that. So,
Okay, we have a lot of stuff
Okay.
remaining on the data store. So let's go ahead and
Yeah.
get Mike
yeah.
working on that.
Okay. Okay, so the third technology and topic we wanted to talk a little bit about, or actually a lot about, we're trying to dedicate a decent amount of the time to this, is query store. So really, really basically, I don't know if there are a number of scenarios, right, where basically performance can basically impact things like availability or cause significant problems basically to your applications. So common examples are, hey, listen, my website is down or not functioning, my application isn't functioning appropriately, the database isn't working or as performant as I expect it to be. I mean, how many people here have basically gotten a late night or early morning call that says, hey, yeah, we're having this problem with performance, right? And how do we go and address that? Or the website's down, or I'm sure everybody would raise their hand. It's late in the day. Or basically you have some kind of temporary performance issue, right? Where it's very, very difficult to basically get to the root cause. What really caused this? Hey, something happened 10 minutes ago. We know we had a spike. Basically, we weren't able to get to the data, but can you tell me what happened? Ever got that question? And then again, kind of another impact that we've seen in particular around performance are things like database upgrades, and if you have basically regressions in particular updates to particular queries. So basically, in a number of these situations, things like plan changes, changes within the core plan that we're executing for SQL Server can cause any and all of these problems. Has anybody experienced problems with basically plan changes? Has a significant impact? Okay. So basically, fixing plan changes and fixing plan choice regressions is pretty difficult with the technology that we have today. So plan cache, if you basically queried plan cache, I don't know if anybody basically will do typical queries of basically their plan cache and maybe save that off and store it or do some historical trending on it or something like that. But it's not really ideal for performance troubleshooting as it is even with the DMVs as we have them kind of today. Basically, it can take a long time to detect issues. The question is things like what query is slow, why is it slow, what was happening previously versus what was happening, now versus what was happening yesterday. And then basically with the functionality that you currently have today, there's typically a long time to mitigate. In essence, like even if you go and find out, hey, listen, this query wasn't performing that well, what are your options to mitigate? How do you do that? Do you do something like forcing a plan? Do you use a plan guide? Something of that nature. Do you have to look at rewriting some of the query, et cetera, et cetera. So these are all kind of difficult ways that are hard to basically fix a bad performing plan. So the solution that we have is Query Store. Basically, what Query Store is it's a dedicated store in the database. It's a database level configuration that stores query workload performance data. This is actually, as well, I should mention that this was actually one of our born first in cloud type scenarios. So this is in Azure SQL DB. This is also in SQL Server 2016. What Query Store allows you to do is capture the history of plans for each query. It will capture basically runtime performance statistics for those queries as well. And then it will persist that data. So this data can be valid basically over restarts, over server failovers, over upgrades, etc. So you basically get a historical view of how basically these queries have been performing. So the advantage of Query Store is this can significantly reduce basically the time to detect and the time to mitigation that we talked about on the previous slide. So instead of basically having to keep all this historical data on your own and basically query through it and having a lot of knowledge about particular calls and the applications, you can find regressions and other issues basically in kind of seconds. And will allow you to basically force plans with the touch of a button. So ultimately, the way that we kind of see this feature is this gives the DBA a lot more control. So let's talk a little bit about some of the key usage scenarios. And this kind of goes from basically a short-term kind of tactical approach to a longer-term strategic approach. And we'll kind of hammer on this on this slide, and then we'll come up with some other kind of broader scenarios that we've done, that we've worked on in a few slides. Quick question.
Where does it store this information?
Yeah, so the question is, where does it store this information? It's basically in the database that, I'm sorry, in the user database, yes. Yes. And we'll do a demo, and I'll show you basically how to configure it, and I'll show you basically all the configuration options. But yes, it's in the user database, and it's very database, it's a database-centric technology. So if you think about it from basically short-term tactical to long-term strategic, again, in the shorter term, finding and fixing any query plan regressions. You can definitely do that with Query Store. Identifying the top resource consumers. We have a nice interface where you can basically say, hey, which queries have basically taken the most resources on my box. You can look at it via CPU. You can look at it via I/O. We track all these metrics, and we'll track runtime statistics for these as well. So it's not just information like show plan, which is basically estimates. So we're actually tracking the runtime statistics as well. One of the core concepts and what we're trying to do is basically de-risk SQL Server or application upgrades. So if I make changes that may change particular plans, our goal is to basically give you that current view or that historical view of how your query is executed. So provide basically a lot less risk. In terms of basically upgrading, for example, the SQL Server 2016, we have tied a lot of the plan changes. We've tied actually all plan changes and things of that nature to new database compatibility levels. So if we were talking about basically using Query Store, which we're recommending in terms of basically upgrading, kind of minimizing the risk there, you may want to basically take your current database compatibility level, 110, 120. We have a new one for SQL Server 2016, which is 130. Again, that has enhancements, but it also could have plan changes there. And so the recommended upgrade path is basically keep your current DB compat level, turn on Query Store, do your upgrade. You're at the same DB compat level. You can change to the newer DB compat level. And if you have problems with one or two queries, you can use Query Store to revert back those particular queries to what you had before. So it can really help out, again, around just perf impact and changes. And then this is another interesting scenario, which is deeply analyze workload patterns. I mean, you can basically utilize Query Store to really look at your workload, find different patterns. Some of this is a little bit more manual, but I think you'll see that we have some pretty nice interfaces around this as well. So I'm going to go through this somewhat quickly. We do have a nice kind of interface, GUI interface for this in SQL Server Management Studio. We also, and I'll go through this in the demo a little bit, we also have these all as DMVs, so you can basically query this information as well. So this is an example of basically data-driven troubleshooting. Just a couple of the lower level scenarios and how you might go about basically looking at some of the data that we get and capture in Query Store. So we have this DMV, sys Query Store runtime stats. where I can get basically plan IDs and I can get runtime stats interval IDs as well. And what this query, or I'm sorry, what this DMV basically gives you is averages, mins, max, standard deviations across a large number of factors. So as you can see, duration, CPU time, degree of parallelism, max memory used per query, et cetera, right? All common things that are pretty difficult to find, in particular if you're not storing this data somewhere. So let's just talk about basically looking at some of these attributes and how would I basically use this data to think about basically troubleshooting. So duration, right? That can definitely tell me what queries are slow, right? I can look at actually different intervals to find basically, was a query slow here? Was it slow at another period of time? So I can find basically query regressions over a particular period of time as well, just basically using duration. CPU time, I can pinpoint CPU intensive queries. Kind of the reverse of this, and this is one of the features that we don't have currently integrated with Query Store, but it has been asked, is around weights. So do a lot of people here use like SysDMOS weight stats to troubleshoot and look at our weights and queues? So that's a typical troubleshooting mechanism that we use in SQL Server. But even just looking at CPU time and comparing that to duration. So if my CPU time is very low and my duration is very high for a particular query, then I can assume that there's some type of weights in the system, right? And basically go and find that. So I can get that all just from CPU time from this DMV. So I can pinpoint I/O intensive queries. I can check if degree of parallelism may be an issue. Do I get different execution plans with different degrees of parallelism? I see row counts, so we'll give you actual row counts. So has the data statistics changed, for example, right? Do I get different cardinality estimation? And we do separate CLR time as well, specifically call that out, so if you have some CLR calls as well. There's also count executions, so I can determine queries that are frequently utilized. Are they ad hoc? Are they regular queries? We actually will tell you whether it's an ad hoc query or basically a stored procedure. And execution time type. So we actually, if particular queries were canceled or failed or whatever, we'll give you information about that as well. So actually, and I talk about a little bit this on the next slide, there are a number of kind of scenarios that people have really looked at Query Store for helping them out. So we talked a little bit about plan change regression, and so that's a pretty canonical one. Again, as I mentioned previously, degree of parallelism, memory grants, execution variability in plans. You can see all that basically through the Query Store. So it's a great way of testing there. Identifying ad hoc workloads. So basically, we will tell you if this query is coming in and it's a stored procedure or if it's an ad hoc workload. So Query Store may be an interesting tool to basically utilize to understand more about what application code is generating, right? You can go back and basically query the Query Store to basically understand, am I getting a lot of ad hoc calls, right? Hey, what happened? What was slow 10 minutes ago? Oh, well, John or Sue decided to basically run this stuff that I didn't know anything about. And basically, you can go and find that ad hoc call in the Query Store. A versus B testing. So this would be maybe I make some kind of a schema change, or basically I do some kind of baseline, and then I basically may want to change either some piece of the query, or I may want to change, for example, database compatibility level, and see how basically my queries perform with a new database compatibility level. So we had a customer in the lab about a month ago, and that's exactly what we did. When we were basically baselining their environment, they are on SQL Server 2014. We basically enabled Query Store. We ran all their workload, their very, very large website. We ran their workload, captured it in Query Store, basically saved off all the historical data. And then we basically changed the DB compat level. because they had some problems with DB compat level in 120, and we're on 110. And then we basically just reran the workload, right? Or if we made slight modifications to the workload, we reran that, and we had all the historical data that we could compare in Query Store. So very nice for baseline versus deviation from baseline testing. And then reducing risk, particularly around upgrade, and then basically resiliency through restarts, through failover. Has anybody ever basically had a failover of a system or moved it to a different server or something like that and basically got different performance characteristics? So, but again, here you can go back to Query Store and basically utilize that as your source of historical truth. So just to emphasize this a little bit more, this is definitely one of the core scenarios that we really see Query Store being heavily utilized for, in particular as people are going up to SQL Server 2016, which is to maintain stability after the upgrade. As I mentioned, that we've tied plan changes to new database compatibility levels. So if we know, basically, for example, we're going to take advantage of a different plan, parallel select into, that's actually tied to DB compat level 120. If you're running in DB compat level 110, you would not get parallelism on select into. That was a feature we had in SQL Server 2014. Batch mode sort with column store. That's something that we basically have in SQL Server 2016. That's tied to DB compat level 130. If you're running in DB compat level 120, you won't get that functionality. Again, we've tied plan changes to different DB compat levels, again, because that can be very impactful, in particular when you upgrade. So the recommendation on upgrade, and we hope that this makes it much easier to basically do the upgrade and basically de-risk a lot of the upgrade, in particular around performance, is, again, consider upgrading to SQL Server 2016, and you can stay at your current DB compat level. Then enable the Query Store, capture your plans, and then basically you have your baseline on SQL Server 2016. With all the plans, we should not get any plan changes there as long as you're under the same DB compat level. You can set the database compatibility level to 130, which has that additional functionality. And then you can use Query Store to force old plans quickly if you do find any regression. Of course, you can also use Query Store to go back and look at those different plans, even if you do force a particular plan, and figure out what the differences are, right? So it has all that historical information, and you may choose to do something else after that and not necessarily force the plan. You can force plans, you can unforce plans as well.
The thing about it is it's really quick. I have a customer that actually had a regression when they actually upgraded 2016 using NCI over CCI. And it literally took them less than 5 minutes to find out the plan changes. And they went about and make changes to their table structure to resolve that. So real easy to use. And again, a lot of the tools are really great out there. So Mike's going to show you with the GUI.
Yep, question.
Is the query plan, the database, is it same like calling the DMDs and DMLabs every minute? How frequently does the plans get stored in the query?
Okay. Yeah, so the question is, if you have Query Store, how frequently, basically, what's the overhead and the impact? In particular, concerns around, hey, listen, if we're basically pulling this data through all the time, there's probably some impact to performance. So I'm going to actually answer that in two or three particular ways. So one, I'm just going to actually talk about the overall perf considerations. And let me know if I don't answer your question, but that's actually a very common question, right? Hey, what's the performance impact? And I'll show you as I go through and configure Query Store that there are some options that you can have that may impact that as well. But I could say that a goal for the team is we really want this to be the de facto, hey, I enable Query Store, and it's not a problem to any workload. I mean, we think that the functionality is so beneficial to so many people. The goal is negligible impact to any workload. not necessarily quite there, but all the customers that we brought in, like I said, I've worked with some major websites. For the most part, we've seen very, very minimal impact to their extremely heavy, low latency type workloads on this. Go ahead.
So currently what we do is we have really stored historical data,
Yep.
say DMVs and DMWebs, because they get reset after every time a SQL Server gets restarted or rebooted. So we basically run a SQL Server job, maybe every minute or every 5 minutes. So is it internally doing the same thing or is it doing something different?
Yeah. So let me start with the first, which is on configuring Query Store, and we'll go through the options. And then if you still have some questions about it, then we can definitely go from there. So, okay, yeah, that's fine. That's fine. Okay, so basically, I just have my Query Store test database here. And if I just go to the properties of this, you'll see that, and if people cannot see it in the back, just let me know, and I'll try and zoom it more. Just raise your hand. But you'll see basically there's this Query Store tab. And so I just want to briefly kind of go through some of the functionality here. So again, Query Store by default is off. You can enable it. It's at the database level. And there are really two types of operation modes that you can have. You can have basically read-write. Well, you can have off, but then you basically have read-write or read-only. So read-write basically means we're going to write to the query store, and so we'll input additional plans and queries. Read-only basically means, hey, I can utilize Query Store, I can take historical data, I can pin certain plans, but we're not going to basically be updating it. And I should mention that all of these updates are in an asynchronous fashion. So if I'm running a particular transaction, it's not like I'm going to basically have to extend the life of that transaction to basically write to the Query Store. So some of the considerations around basically impact to performance, you'll see kind of on this monitoring side, we have this data flush interval in terms of minutes, and we have this statistics collection interval, which I think actually probably goes more towards your question. So on the data flush interval, this is basically, for lack of a better term, how much data am I willing to get rid of versus how much data if I have, say, a failure, right? So this is basically, if I set my data flush interval at 15 minutes, we're storing all the data, and it happens to be in memory, and then we will flush it to disk every 15 minutes. So if the server restarts and it's on that period, we'll lose that last 15 minutes worth of data. That seems, in general, again, in talking to some customers and working with that seems fairly reasonable. I think the granularity down here is down to about a minute. Yeah, that's in minutes. And then the statistical collection interval, basically that's how often are we going to basically collect these real-time statistics. So again, there you can specify 1 minute, you can specify 5 minutes, 10 minutes, et cetera. So the granularity is on a minute interval. And so that's what we'll do. Actually, within that interval, we'll show basically one data point within each of those intervals as you start looking at the GUI. So there was a question earlier about, hey, where's this data actually stored? We do have some, we call it the Query Store retention. We do have a maximum size that you can specify for the Query Store. Then we also have and basically I should comment that once you hit that size, we'll just turn, if you're in read-write, if you hit that size, we'll just turn it to read-only. So you won't be able to basically update the Query Store anymore, but you'll still be able to utilize that functionality. So as it relates to that, if you specify a certain size, if you specify 100 meg or something like that, we do have this size-based cleanup mode. So it's off, I think, by default, but you can turn that to auto. And again, that means that we will basically clean up, I think when you get to about 90% full, based on your max size. We have a stale query threshold as well. So if basically queries haven't been executed in a certain number of time, happens to default to around a year, then you can change that, right? And then that can get rid of those stale queries. We also have a query store capture mode, and so this has basically all, none, or auto. So all basically means any query that comes in, we're gonna capture that and put that in the query store. For auto, we won't capture ad hoc queries. We also won't capture, you're basically letting the system basically decide which queries to capture. So we'll look for the critical ones. We won't capture ad hoc, and we won't capture like no-cost plans in that particular case.
Can you specify where the query store data actually resides?
Yeah, so the question is, where does the query store data actually reside? Right now, it's on disk. It's going to be in the primary file group. And there's no way to, at the moment, there's no way to basically specify another file group. But that would be good feedback if that is something that definitely is required. So, so that again is basically a lot of the core considerations about basically setting up the query store. So now let's just kind of go through a example and basically look at a couple of the dynamic management views around it, and then I'll show you the GUI, which actually I think is probably the best piece. So what I'm going to do here is basically I'm just going to clear my query store and free my proc cache. And I should mention that basically I'll query two views that I created that basically combine some of these DMVs to get some more specific statistics. So I'm going to go ahead and use query store, and let's just run a simple query. Select star from part in my particular table. So the first, I'm basically going to look at four DMVs here. First is the query store query text. So basically I can go ahead and select that, and you can see my SQL text. I have a text ID. I have some statement handles as well, so I can probably join that. May join that a little bit later on to some other DMVs. This just tells you a lot of statistics about the query text as well, right? Is it part of an encrypted module? Does it have restricted text? So next I'll just go ahead and select from the query store query. This is giving me a little bit more information. So this is giving me the query ID, some context setting IDs, query hash, some query parameterization types. It's giving me some information about the initial compile start time and last compile time. And it's also giving me things like compile duration and some of the duration statistics. Then there's the query store plan. This actually has my my query plan, my show plan type information. And ultimately my query store runtime stats, which is definitely a big one. So this tells me basically things like the execution type, when was it first executed, when was the last execution time, and things like duration, CPU, I/O, et cetera, et cetera. So I did create this custom view. This, again, I'm not going to go through this too much in depth, but this is kind of combining a number of these factions. So basically, I can get things like the statement handle and other considerations around the last compile start time, the last time this was executed, et cetera. So I just want to give a couple of more data points in this, and then we'll kind of get to the GUI one. One important thing to consider is basically execution context. So I have this stored procedure that basically is running the same select statement. and I go ahead and create that store procedure. And then the third component that I'll do is I'll run this SP execute SQL, which again is just doing my select star from part. And so if I look where previously I basically had that one entry for basically the query that was select star from part, now you'll see, actually I missed one. Now you'll basically see three. So I had one that was SP execute SQL, one that was just select star from part, and one that was the stored proc. So basically this will show us basically three different types of plans. I have a fourth example here where I was using a trigger and using some of the drop if exist type syntax as well. And there you would see basically a fourth context plan. So this actually does matter. Actually, one of the testing that we did, if you have a lot of comments in your store procedures, that can basically generate kind of different rows for this as well. So the last kind of piece that I wanted to mention around here, and then I'll show you some of the GUI, is parameterized queries. And this is something to be careful about if you have simple parameterization. So if I do a select from part where the part ID is equal to 5, and then I basically am doing that same query. This is just, again, a view that's joining on some of those DMVs. I'm not going to get any data here. So what does this really mean? If I go to the query store text query, if you look at this, we parameterize the query. So we do have some functions, this FN statement SQL handle from SQL statement, and you can pass in if you know basically the query with that parameter that you're passing. So here, if I run this particular function, then I could get that information about those parameterized queries. But I just wanted to call that out, that's something to consider in particular for looking at these GUIs. So the last thing that I wanted to do, and I actually think that this is important and I'm actually running long, is I wanted to show you basically, I'll do a quick demo. And of course this isn't aligned with my, all right, so basically here, I'm going to just do a quick demo. This is just executing hundreds of stored procedures. And here's the GUI, so for query store. So I think the best thing to do is probably look at the top resource consuming queries. And so you can modify this GUI actually any way you want. If you look at this really quickly, you can see that we're basically looking for the top 25 resource consumers over the last hour. Within that database, again, I can search on duration, I can search on CPU time, execution count, logical reads, writes, etc. Here, I basically, again, I can configure all of this. I can search for stuff in the last hour. I can search for things in the last 5 minutes. I can search for the top 25, top 100, etc. And so here's an example where basically, and actually here I'm getting basically my plans right here as well. So this should start coming up as I execute these queries again. But yeah, so we're going to start getting this. In this particular example, the query that I'm running, you can kind of see that basically I'm getting these two plans, and this happens a lot with basically, this is kind of some skewed. Basically, I'm passing in different parameters, and my data is a little bit skewed, so I'm basically getting these two types of plans for this one particular query. So I can go over here and look at it. I can look at this particular query. I can look at this other query. I can see that they're basically the same query. So we talked about basically, hey, how do I basically pin plans if I want basically it always to use the good plan here. And that's actually as simple as right here, just doing a force plan. In this particular case, as you would typically see it as they keep on coming up again, you'll see that basically I just forced that particular plan. So whenever that query context comes in, it should use basically my good plan. If you want to see this actually over time, again, just another view, and you can do this a different way. You can have this tracked queries. So I can basically track this query, and I can have this auto updating, and then basically over time, basically on the interval that I can configure it, and the auto update interval being 5 seconds, this will basically just continue to auto update. And there, in this particular case, you can see that third one on that plan, it's checked, and so it should always use that lower plan. So I know we basically ran out of time, but I did just want to comment that there are, there are things for regress queries here. There's overall resource consumption, which is really interesting if you wanted to see overall resource consumption, say, again, you can look at durations, execution count, CPU time, logical reads. You can specify the configuration and basically the scope for all those things. Even here, if you want to basically view, not view the queries, I wanted to show. On the top resource consumers, I can do more of a portrait view of this. I can even, instead of looking at the plans through a GUI, I can basically see just like what I would see basically in those DMVs for the execution time, total duration, etc. So really nice, I think, interface on that. So I apologize for going over. We have one more slide, and then we'll be around for questions. So CTP3 and beyond, we just wanted to quickly just give you the view of what's going in basically to 2016 for these 3 features. And if you tested on earlier versions, so Temporal, alter column and in-memory OLTP and StretchDB support all came in CTP3. Integration with SSDT is actually definitely a big thing that we want to have, always encrypted, and an at-time zone functionality that's coming in for SQL 2016 for JSON. With CTP3, we released a lot of the built-in functions and OpenJSON. Those just came in, and as I mentioned, this will go into Azure. That's coming. And for Query Store, we have in-memory OLTP support as well. So we can basically take native compiled store procedures and modules and look at them in the Query Store. That is the CTP3 hyperlink. And here are basically kind of the key takeaways that we wanted to get out of this. So with that, I appreciate you all staying a little bit later. More than open to questions here and or offline. I'm sorry, can you repeat the question?
Are you coming? Okay.
Yeah.
I've got like 2 minutes.
Okay, sure. Okay, sorry.
Yeah. So
Okay,
question
no,
on anything similar for analysis services. Analysis services actually does have, this is my rudimentary understanding of analysis services. Analysis services, actually we've added a lot of extended events that should actually help you with query perf. And actually we've done a lot of enhancements to the AS engine around overall scale and perf. So we've added the X events, nothing in Query Store specifically yet. Good question, good question.
He has to set up in 2 minutes, so we'll be
Oh.
standing outside, and you can be
Okay,
more than welcome.
thank you very much. You